I'm going to first show you where to get the documents. So here's Unit 1. Because normal distribution's in Unit 1, we need something from there. Tables are in here. They'll apply to more than one unit by the end, so they're not in a unit. So in Unit 1, here are the videos already created, and then down here is where I'm going to put the normal distribution one. So this is where the notes are. So now we have normal distribution and our tables. And the normal distribution uses Z tables and also T tables is sort of normal, not exactly. So different tables show different areas. Ours shows to the left always. So we have to work with things, to the right is the T table. So we have these, I guess, 2 pages. I'm going to let you read this to yourself instead of my reading it to you. You can pause the screen here and read it, or you can read it off the notes. You can download, print them, whatever. The empirical rule is not an exact measure, so when you're asked to calculate something, you should not use that. If you're asked to use the empirical rule, or if you're asked approximately, then you can use the empirical rule. But for calculate or find, don't use that. This is the shape generally of the normal distribution. This where what's called concavity changes. Right here, that's at 1 standard deviation away. So the middle is the mean. If you add a standard deviation, you get right there. You subtract 1 standard deviation, you get there. So we've already talked about how to calculate the mean and the standard deviation. So if you just add 1 and subtract 1, you get this 68% between. And sometimes that's referred to as about 2/3. But at any rate, 68, I think 0.27% or something like that, but 68% is between 1 standard deviation away on either direction. Again, our chart always gives to the left. The empirical rule talks about the middle amount. If you go 2 standard deviations in either direction, so you add 2 times the standard deviation, subtract 2 times the standard deviation, then you get like 95-ish%. But again, if you're asked for the middle 95%, don't say 2. It's something like 1.96. It's not exactly 2. And then 3 gives you almost everyone. So if you add 3 standard deviations and subtract 3 standard deviations from something which is normally distributed, then you'll get 99.7% of all people in there. Sorry I had to pause there. Hopefully I come back at a normal way. So if you are given the mean and standard deviation, then you can kind of label these spots, and then you know there's 34% in here and 34% in here because it's symmetric. So if there's 68, then there's half and half. You already know how to calculate mean and standard deviation. So from here, whoa, that's weird. I'm gonna just start that over. Okay, so once we have this, then labeling the parameters is, first you put the mean right here. So this mean is 55.9. You move 1 over and you add a standard deviation. The standard deviation is 5.7, so I add that and I get 61.6. To get to the next one, I add another 5.7, so 67.3. And then I add another 5.7 to get to this one, and I get 73. Over here, I subtract 5.7 because I'm going the other direction. And then I subtract another 5.7. And then I subtract another 5.7. And that's how I label the parameters. So, to shade the region that represents the proportion of 10-year-old males who are less than 50.2, I guess I should have left those labels, shouldn't I? So I had them labeled before, and 50.2 was this one right here. So less than 50.2 is take this and shade that all in, because less is to the left. Suppose the area under the normal curve to the left of 50.2 is 0.1587. What that means is that 0.1587 of all 10-year-old boys are shorter than 50.2 inches. So the standard normal distribution, which is after everything's been put in standard units, the mean is 0, standard deviation is just 1, so that when you label this thing, it's 0, 1, 2, 3, negative 1, negative 2, negative 3, just like that. You can read this. The way you normalize things is by finding their z-score. It's also called their standard units. So you take your value, you subtract the mean, that's this right here, and then you divide by the standard deviation. So if this is mu, you'll get 0 up there. If this is the guy 1 standard deviation away, then when you subtract, you'll get a standard deviation. You'll divide by the standard deviation. You'll get 1. If you were 2 standard deviations away, you'd have 2 standard deviations up here. Divide by standard deviation, you get 2. So it's just a relabeling where you've thrown away the units, and everything is therefore standardized. Okay, always round a z-score to 2 decimals, area is always to 4. That is what's on your table, okay? So I'm going to do one of these, and then I'm going to let you do the other. So I take the curve. 2.29 is going to be on the right because we're in z-scores. So here's 0, 2.29 is over here. And I want that tail, right? So I just look here. First I find 2.2 on the left-hand side. This is like a stem and leaf plot, right? 2.2 is there. And then 9 is the last one. You can look up here, it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2.29 is right here, 0.9890. Now you do the next one, which is less than negative 1.09. Hopefully you paused there. If not, you should do it now. And now we find our way to here, and it's right there. Okay, same thing. I'm going to do one, and then you pause, and then you try the other. So greater than 2. Because my chart always gives less than, I'm going to have to subtract from 1. I go over here, I find 2.00. That's the part that's to the left. Because I want this part over here, and I know this is 0.9773, I subtract. And that's the part to the right. Okay, now you pause and do this one. So negative 1.02, there's 0, 1, 2. It's right there. So I subtract that and I get 0.8461. You should have gotten 0.8461. I'm going to do this in between. So I have between 0 and 1.25. Okay, I actually know this is 0.5 because it's symmetric, but I can also look on the chart at 0, 0, 0, right there, 0.5 is to the left. And then I look up 1.25, 1.20, 1, 2, 3, 4, 5, 0.8944. But I just want this part here. So because there's 0.5 over there, for this, I need to take that 0.8944 and subtract off the bit that's already to the left. So that's the answer to the first one. Now you go back and do the second one. So you should have gotten this to find this bit in between, 0.3939. Okay, so now we are going backward. We want the z-score so that the area is 0.026 to the left. So I'll do the first one. Now I'm looking in here, in all these, for the thing nearest 0.026. 0.02611, 2579, so that's 0.0021 away. That's 0.0011 away. This is the closest. So negative 0.601234. Negative 0.64 is the answer. Now, you do the next one, pause, and find the one so that to the left is 0.993. Okay, so you should have chosen one of these two. They're the same distance away. So 2.4, 1, 2, 3, 4, 5, 2.40, 1, 2, 3, 4, 5, 6. So 2.46 is the answer. And then I want to find the one where the z-score cutoff is P70. That's the 70th percentile. So that means I want 0.7 to be to the left. So look for 0.7. This is the closest to 0.7. So 0.5012, 0.52. Okay, now we're going to do it to the right. So the thing that we do now is if 0.433 is to the right, I subtract that from 1. 1 minus 0.433 is 0.567. So I come over here and I find 0.567 right there. And it's 0.1, 0, 1, 2, 3, 4, 5, 6, 7, 0.17. Now you do this one. To the right is 0.971. Pause. So you should have looked for 0.029. So minus 1.90. And now we want to find the one that has the middle 70%. So let me draw that. Okay, so the middle 70% is like that. So the question is, what is this, right? Well, there's 0.3 total. between these two, because the whole thing adds up to 1, that means there's 0.15 over here. So 0.85 is the total to the left. So I look for 0.85 right there. 1.001234, 1.04. Okay, so if you are not given a z-score, if you are given a score, the way to change it to a z-score is just as before, subtract the mean, and then divide that difference by the standard deviation. Okay, so if women's heights are normally distributed with this mean and this standard deviation, if we want the probability a randomly selected woman will be taller than 62 inches, then the first thing is to find the z-score for that. Okay, so the first thing is the z-score for the 62-inch person. Over here, by the way, 63.6 is here, so 62 is going to be over there. And we're going to want taller, so this is what we want. If you sketch it, it'll help you kind of figure out what to do. Just make sure and put them in the right order. So 62 minus 63.6. By the way, this formula is on the chart. So that's minus 1.6 over 2.5 is minus 0.64. So that's their z-score. So if I go look up that z-score, minus 0.601234, 0.2611. 0.2611. But this isn't what I want. This is what I want. So 1 minus 0.2611, 0.7389. Okay, and then between 63.6 and 71, is going to be over here, and now we want this split thing. Again, because this is the mean, I can go ahead and put that 0.5. I don't have to calculate that. If I do 63.6 minus 63.6, it'll be 0. If you look up 0, you'll get 0.5. So I'm just going to do this one z-score just because I don't have to do it. If it was something other than 63.6, you'd have to do it. So let's see, 7.4. Okay, so I think that's 2.96. You can check me and see if I'm wrong. 2.90123456.9985. But I have to take out that 0.5. Okay. So now I'd like you to do this one. Okay, so for that example, you should have gotten 0.1492. It was already left-hand tail, so you didn't have to subtract anything. Okay, so now this is the going backward where you're not given the z-score. Okay, so we're back to this, or I'm back to this, and you're going to be back to the other. So these people only accept the tallest 10% of women. So they only select where 0.1 is up here. This is their cutoff right there. Down here then there's 0.9. So we want to know what the cutoff is. Well, the first thing is to find out the z-score that's the cutoff. So I go here and I'm looking for 0.9 down here in the area boxes. And this is the closest to 0.9. So 1.28. So z is 1.28. So this time I found z from the chart. Rather than finding z from the values and finding the area from the chart, I took the area to the chart to find z. So then I can use the normal formula where z equals x minus mu over sigma, and then you can sort of, sort it out from there, or you can use this one. X is, if you start from the mean, you go z standard deviations away from the mean. So if z is negative, then this will end up subtracting, but it's always mu plus z sigma. So x equals 63.6 plus 1.28 times 2.5, which is 66.8 inches. Okay, now you do this one. Okay, so for this one, you should have first gotten 172 words per minute. You should not have used 2 because it did not say approximate, and that would have been using the empirical rule. But then also the cutoff points were unusual in either direction. So you could have used the 0.025 to find the negative z, or you can use the 0.975 to find the positive z, but you had to do them both so that you ended up with both of these. IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. People are considered intellectually very superior if their score is above 130. What percentage of people are above 130? So 130 minus 100. The minute it asks for proportion, we know we need to calculate the z-score if it's normally distributed. So that equals 2. So we go to the chart, 2.00, 0.9773. But we don't want these guys, we want these guys. These guys are 0.0227. So that's the proportion of people considered intellectually superior. Now you pause it and you do if we redefine it. So now it's actually just 1%. So you should have done something like this one, found the z-score, plugged in, and got 135. Okay, this is the last page. So the lengths of human pregnancies are approximately normally distributed with a mean of 266 days and a standard deviation of 16. In a letter to Dear Abby, a wife claimed to have given birth 301 days after her husband visited from his stint in the Navy. So given this, find the probability of a pregnancy lasting more than 300 days, which 301 is more than. So we want to know, this is 300, what's the probability over here? Okay, so z equals 300 minus 266 over 16. Have to round, so 2.13. 0.9834. So that leaves over here 0.1166. No, sorry, 0.166. So, not that close to 0. So the result might suggest that the husband might be concerned, but it's within the realm of possibility. Okay, now you pause and do this one. I should have done these in the opposite order since I had you do one like this last time, but that's okay. You pause and do this one, and this is the last bit. So you should have done something like this. You found the z-score from that bottom 0.04 and then plugged in and found 238 days. Hopefully this clears up a lot of stuff and you'll all do well on the REQ and then on the exam.